In this example, we're asked to determine the measure of the unknown angles. So looking at part A, we have two sides in a right angle triangle, and that's enough to determine one of the angles here. So the first step is to label the given sides. So the 12-meter side is going to be the hypotenuse. It's the longest side across from 90-degree angle. And then the 5-meter side is going to be our adjacent side because it is next to the angle that we're trying to find, and I know that the hypotenuse and the adjacent side always form the angle that's used in the question. Okay, so after that, we determine the primary trig ratio that we're going to use. The ratio that contains or uses these two sides, the adjacent and the hypotenuse, is the cosine ratio. So I'm going to write that primary trig ratio. So cos theta is equal to adjacent over hypotenuse. Next step is just to sub in those values, leaving theta as our variable that we're trying to find. So the adjacent side is 5 and the hypotenuse is 12. And since we're looking for the angle, we now are going to use the inverse of cosine to determine it. So theta will equal to inverse theta followed by the ratio of 5 over 12. So I'm going to enter that information here to the calculator, just the way I see it on paper. And that gives me an answer of 65.38 when rounded to 2 decimal places. So that's the answer for the angle in part A. Let's look at part B. Again, first step is to label the sides. The 8-centimeter side is going to be the opposite side. The 6-centimeter side is going to be the adjacent side. The primary trig ratio that contains those two sides is the tangent ratio. And then I'm going to sub in the values in the next step, leaving theta as a variable. So I get 8 over 6 on the right side. Finally, to find theta, I take the inverse. Tan, followed by the ratio. And then using my calculator, I get an answer of 53.13 degrees. Example 2, a road rises 15 meters over a distance of 100 meters along its surface. Determine the angle of inclination of the road. So I can draw a picture of the road. It'll be in the shape of a triangle here, right angle triangle. It's rising vertically a distance of 15 meters over a distance of 100 meters along its surface. So this is the surface of the road along which cars and other vehicles travel. So this would be 100 meters. And we're asked to determine the angle of inclination. So the angle of inclination is the angle that's formed between this diagonal and this horizontal line. So this is the angle that we're looking for. So we're going to first label the two sides involved in the problem in relation to this angle here, and I'm just going to call it theta. The 15-meter side is our opposite side, and the 100-meter side, because it's the longest side and is across from the 90, is the hypotenuse. The primary trig ratio that contains the opposite side and the hypotenuse is sine. So sine of angle theta is equal to opposite over the hypotenuse. I'm going to sub in the values for the opposite and the hypotenuse sides. And I will get sine theta is equal to 15 over 100. To figure out what theta is, I have to take sine inverse of this ratio. Make sure your calculator, again, is in degree mode. And depending on the calculator, you either enter it the way you see it, or you might have to enter the ratio first. But the final answer is 8.63 degrees when rounded to 2 decimal places. And then since it's a word problem, we're going to write a therefore statement. Therefore, the angle of inclination of the road is 8.63 degrees.